Now let's take more examples on simplifying trig expressions using fundamental trig identities. Before we continue, let's recall on the three fundamental trig identities, where we have sine squared theta plus cos squared theta is equals to 1. When we divide all through by sine, we will have that 1 plus cot squared theta is equals to cosec squared theta. And when we divide all through by cos, we will have that tan squared theta plus 1 is equals to sec squared theta. So interestingly, we solved some questions proving the validity of these expressions. Now let's just take some more examples to prove the point or to establish understanding. The first example we'll take is that we want to prove that the root of 1 plus cos theta divided by 1 minus cos theta is equivalent to cosec theta plus cot theta. So yes, you can as well pause the video, give this a try, and we'll solve it together. Remember, we are going from the left hand side to the right hand side. So with that, let's begin from the left hand side. We have root 1 plus cos theta divided by 1 minus cos theta. According to the rule of surd, you can watch more lesson video on surds, that we arrived at root a divided by root b is equivalent to root a over b. Similarly, root ab is equivalent to root a multiplied by root b. So applying the first rule of surd, that's the division rule, we will have that root 1 plus cos theta divided by 1 minus cos theta is equivalent to root 1 plus cos theta divided by root 1 minus cos theta. Now, what we are going to do next is to multiply the numerator and denominator by the conjugate of the denominator. This will learn on the rationalizing of the denominator. So watch more lesson video on rationalizing the denominator in the surd course. Rationalizing the denominator, where we'll multiply the numerator and the denominator by the conjugate of the denominator. So this is the denominator here, root 1 minus cos theta. So the conjugate of that the conjugate of 1 minus cos theta is 1 plus cos theta. So we'll multiply it by root 1 plus cos theta, and also multiply this by root 1 plus cos theta. So simplifying further, we'll multiply the numerator and the denominator together. So we have common terms here. So root 1 plus cos theta multiplied by root 1 plus cos theta is simply saying it is 1 plus cos theta, because the square root will nullify the square root. Likewise, root 1 minus cos theta multiplied by root 1 plus cos theta, that means we have root 1 minus cos theta. Let's take this one a step backwards for more understanding. So we are saying this is root 1 plus cos theta being multiplied by root 1 plus cos theta. And this is root 1 plus cos theta. So moving on, applying this second rule of surds to this expression now, that root ab is equals to root a multiplied by root b. So this is multiplication and this is multiplication. So we'll have this, the square roots will come together, and we'll have 1 plus cos theta, and likewise we'll have 1 plus cos theta. We are establishing understanding, and the square root of the denominator will result into 1 minus cos theta multiplied by 1 minus 1 plus cos theta. Now the numerator will be 1 plus cos theta squared, and the denominator will be square root of 1 minus cos squared theta. because we're applying the difference of 2 squared. And in the difference of 2 squared, we understand vividly that x squared minus y squared is equals to x plus y multiplied by x minus y. This we applied in the last lesson video. Now, let's recall now the 3 trigonometric functions, and we will have that sine squared theta plus cos squared theta is equals to 1. And when we making sine squared theta, so the formula here, we'll have that sine squared theta is equals to 1 minus cos squared theta. And if you make cos squared theta, so with the formula, we'll have it to give us 1 minus sine squared theta. So now we have an expression of 1 minus cos squared theta, which is equals to what? Sine squared theta. So moving on, let's simplify the numerator. We have a square root and we also have square, so they will nullify each other. So we'll have 1 plus cos theta, and the denominator will be simply sine squared theta square root. Now, just like we have in the numerator, this will be simplified further to give us 1 plus cos theta divided by sine theta. Now remember, we are moving towards the right hand side, which says sine cosec theta plus cot theta. So let's split the denominator or the LCM. So we have to give us 1 over sine theta plus cos theta divided by sine theta. Now this final length is just going to be depend on reciprocal functions. So let's resolve on reciprocal identity functions. That cosec squared theta is equals to 1 over sine theta. So cosec theta is equals to 1 over sine theta, and sec theta is equals to 1 over cos theta. Moving on, that cot theta is equals to 1 over tan theta, and tan theta is equals to sine theta divided by cos theta. And if sine theta divided by cos theta is applied here, we will have that cot theta is equals to cos theta divided by sine theta. So now let's apply this concept. Cos theta divided by sine theta is this, and similarly 1 divided by sine theta is this. So we can therefore make the substitution that 1 divided by sine theta is cosec theta, and cos theta divided by sine theta is cot theta, which is equivalent to what we have in the right hand side. That the square root of 1 plus cos theta divided by 1 minus cos theta is equals to cosec theta plus cot theta. So this we have expressed. Let's take another example to establish understanding. Let's call it question number 2. And this time around, we will take a very interesting question, which is also simple, by the way. And now we want to express that sine theta divided by 1 plus cos theta is equal to 1 minus cos theta divided by sine theta. So to simplify this, now we are moving from the left hand side to the right hand side. So let's begin. Sine theta divided by 1 plus cos theta. So to simplify this, we have to multiply the numerator and the denominator by the conjugate of the denominator, just like we did in sorts, or like we did in the previous example. So 1 plus cos theta, then we multiply this by the conjugate of the denominator. The conjugate of the denominator here is 1 minus cos theta, and we do the same thing for the denominator, 1 minus cos theta. This will explain better when you look at sorts. Take a look at sorts in our YouTube channel and you'll get this. So let's open the bracket now. So the denominator will be sine theta multiplied by 1 minus cos theta, and the denominator will be 1 plus cos theta multiplied by 1 minus cos theta. So the numerator now, when we open the brackets, will give us, or we can still leave the brackets in that manner, sine theta divided by multiplied by 1 minus cos theta, and this denominator now is an expression of difference of 2 squared, which we have in the previous example. That's 1, where is it, 1 minus cos theta multiplied by 1 plus cos theta will give us 1 minus cos squared theta, because we are applying difference of 2 squared. So this will give us 1 minus cos squared theta, and 1 minus cos squared theta is equals to sine squared theta. So therefore we have sine theta into 1 minus cos theta divided by sine squared theta. Sine squared theta is sine theta multiplied by 2. Let's rewrite this. Cos theta. Sine squared theta is equals to sine theta multiplied by 2. So we have sine theta multiplied by 1 minus cos theta divided by sine theta multiplied by sine theta. So interestingly, one sine theta will nullify the other sine theta, and we are left with 1 minus cos theta divided by sine theta, which is an expression of the right hand side. So yes, we have simplified this right hand side to give us the right hand side. Now let's take an exercise to validate our understanding on this subject matter.